In this video, my goal is to show you how to use matrices to solve 3 equations and 3 unknowns super fast. In this case, I'm going to use Kirchhoff's laws as an example of how to do this. At this point, I'm going to assume you already have your 1 equation for your junction law and 2 of the 3 possible equations for loop law. Since I need to have 3 equations and 3 unknowns, I don't really need the 4th, in this case, blue, loop. I can deal with just my equations, red for the outer loop and teal for the bottom loop. So our goal is to take these 3 equations and transpose them into a 3x4 matrix. For instance, my first equation would be I1 has a coefficient of 1, I2 has a coefficient of 1, I3 has a coefficient of -1 and equals 0. For my outer equation, this would be 28I1 plus 0I2 plus 16I3 equals 24. And similarly for the bottom. Once I have my equation set and transposed into the matrix of the variables we want, we're going to try to use reduced row echelon form to find our 3 solutions for I1, I2, and I3. But first, we're going to need some calculator magic. We know all the numbers we want to enter into this matrix, so I'm going to go into matrix, that's second, and over here with this inverse button, will bring me into the matrix functions of my calculator. Let's go with matrix A. I'm going to go over to edit and choose to edit matrix A. A is a 3x4 matrix, so I'm going to, if I haven't done this already, enter a 3, enter, then a 4, enter, and start filling in my numbers. So according to the equations we picked out before, this would be 1, enter, 1, enter, -1, enter, and you probably get the picture at this point. We're going to be entering all the values from the matrix we came up with earlier. Now that it's all saved and looks good, we're going to go to second, quit, get back to that main screen. Because we want to work with reduced row echelon form, and that's a matrix function, I'm going to go back into matrix, go to math, and scroll down past all the other matrix functions until we get to reduced row echelon form, which unfortunately is a little far down. But once we get there, that's the function we want, hit enter. Finally, we want it to act on the argument of matrix A. So go back into matrix for the last time, enter A, close it on up there, hit enter, and it will give you a matrix on the left of 1s and 0s, but my last 3 numbers will be your values of I1 is equal to about 0.5, I2 is about equal to 0.15, and I3 is approximately equal to 0.64. Some things to note for matrix math. I've now entered a new matrix B based on different sets of equations for a different problem. Notice for this that it doesn't matter in which order I put my loop and junction laws, as long as I keep my columns in the right place. So column 1 should be all my coefficients for I1, column 2 should be all my coefficients for I2, etc., so that my currents at the end come out in order I1, I2, I3 that we can actually identify. One thing to be careful of, though, is one of the 3 equations, it doesn't matter if it's in the top or the middle or the bottom, one of the 3 does have to be your junction law. A funny thing happens with matrix B, though. If I go to do reduced row echelon form, it gets kind of a funny result that you should know what it means. In this case, when I do reduced row echelon form, it doesn't mean I've entered anything wrong with matrix B, but matrix B returns a negative number for current. And that's totally possible. A negative number for current means that the current is just traveling in the opposite direction that you drew in your diagram to start with. And that's all we have to do for matrices. Thanks for watching.